Okay, so yes, we could do, can I need your attention, please? So yeah, we could do a decimal point, and that would give us the number bigger than 5 and smaller than 9. How about that? Nice job, Johan. Yes. Oh man, did I not do? Okay, so have a look. I want to look at a couple things here. So today we're going to try something new. Right? So let's make a function. I thought I had this thing saved and I can't find it, so I'm going to have to just redo it. That's all right. So we're going to make a function. Let's just start off with, how about, we'll just make it like a square root function. Okay? So somebody, what would we do? Let's just say we wanted to horizontally, here's what we want to do. We want to horizontally stretch this by 4. What would we do?
16.
We'll call that g of x. What would I do to f of x?
16.
What do you think? Caleb?
Radical 1/4 x.
Okay, so I'd multiply, if I want to stretch it by a factor of 4, I'm going to multiply inside, right? I'm going to multiply by 1/4. So I could call that, I've already defined f of x as the square root of x. So we could do that, right? And look what we did. We stretched it. Everybody agree? Okay, so the point that used to be at 1, 1 is now at 4, 1, right? So when we horizontally stretch it, and this is something that's hard to get used to. When we horizontally stretch something, it means that a point is going to retain the same vertical coordinate, right? It's only going to move horizontally, not vertically, okay? What if we wanted to horizontally stretch it by a factor of 4 and we want to translate everything 2 to the left? What would I do? So I'm going to add, what am I going to do? Add 2? Okay. Ooh. That didn't work. Okay, so what do I need? So I need to do the x plus 2 in parentheses, don't I? Right? Okay, that did it. Right? So that translated our blue graph 2 to the left. Remember that when we put things in parentheses like that, if I do like an x plus 2 in parentheses, all that means is we're going to do all the stretching and compressing first, and then we're going to take the finished product and we're going to slide it by that amount. So now what if I also want to translate this thing, let's say 1 down? So outside the parentheses, I'm going to do minus 1. Okay, good. So now here's a challenge for you. Now the topic for the day is reflections. So what do you think if I wanted to reflect, let's say I'm going to go back a step, and I want to reflect this thing over the x-axis. What could I do? What do you mean by negative? Okay, and so I don't really need parentheses right now because there's nothing, it's all enclosed in one thing, right? But if I do a negative, okay, there, we got our reflection. Okay. So now what if I want to take this reflected product and translate it to up? What do I do?
Minus 2 outside the parentheses.
Minus 2? Oh, that took me down. So plus 2, how about? Okay. Everybody see that? Okay. Now, what if I want to do that a little differently? What if I want to, let's say I want to do my reflection afterwards. So I want to do this in this order. I want to go, oh darn it, let's go back. So let's say I want to horizontally stretch it, which I did. I want to horizontally translate it, which I did. Now I want to vertically translate it up by 2 and then reflect it. What would I do? So what am I going to do?
Add 2 outside.
Going to add the 2 outside. And now what happens if I put a negative here? What's going to happen?
It's gonna go all the way over to the other side.
Okay, let's try that. Oh, no, it didn't.
Just because it's not in parentheses.
Okay. If I want to take the whole thing and translate it, I've got to put the whole thing, or take the whole thing and reflect it, sorry. I got to put the whole thing in parentheses.
Oh,
Oh, yeah.
And now it does it. Okay. So,
Put a negative in front of the g of x.
say it again.
If you put a negative in front of the g of x.
Well, I mean, that doesn't make sense because we're trying to define a new function g of x, which we're writing in terms of f of x. Right? Now, I could say h of x equals negative g of x. What's that going to do? You tell me, what's that going to do? If I define, yeah.
Erase that negative there.
Everybody see that?
how do you make it?
Okay.
Like the other way?
Okay. So let's maybe explore this in a little different way. Let's say that g of x now, let's make some sliders here instead. Okay, so let's do this. Let's call this, what's the parameter that controls the horizontal translation? H. So we're going to make that a minus h. What's the vertical translation? K. What's the, let me get rid of this. Okay, what's the horizontal, or what's the vertical dilation? A. What's the horizontal dilation? And that goes there, right? Okay. So let's make sliders for these. So we're going to let A go from, we'll let A go from negative 4 to positive 4 by 1s. Oh, sorry, no, that's what we want for H. Let's let A go from negative 2 to positive 2 by 1/2. And let's let B go from negative 2 to positive 2 by 1/2. I am recording. Yes, I am recording. So there's a translation, right? We've got K is 1, H is 2, so we translated the vertex. What if we let B, we should start off with B1 and A1, right? So we know that if I drag A down to a smaller value, it's going to horizontally compress it, right? Okay. Let's untranslate it first. If I drag B down to a value smaller than 1, it's going to horizontally stretch it, right? If I drag B to a negative value, what's it going to do? It's going to reflect it, right? It's going to reflect it horizontally. If I drag A to a negative value, what's it going to do? Reflect it vertically. Okay? And then I can do my translations after the fact, and it takes that finished product and it translates it, right?
You can make a pretty cool pattern.
You could. Okay?
That's a pretty cool pattern.
So now here's the next question then. What's going to happen? What if I want to? Well, I don't know. I think you guys are you probably got this. Let's try some practice problems. Let's try some practice problems. Okay, so what are we gonna do here? We want, the red graph represents the parent function f of x. The blue graph is g of x. So what's g of x?
Negative f
Everybody agree?
of x.
That g of x in this case, g of x would just equal negative f of x,
Oh, for sure.
right? If we multiply the y value by negative 1, it's just it's just reflecting the thing vertically, and f of x just stands for y, right? How about that? There's our parent graph, there's our reflected graph. What's g of x this time?
That was negative x.
Yeah, Caleb?
Good. If I multiply the horizontal variable, which is x, by negative 1, we get the opposite reflection, right? We get the vertical reflection, okay? So it makes sense, right? Doesn't that make sense? We're multiplying, if we're taking input values, the function, in order for the function, kind of see if we can reason through this a little bit. If we were to make a table of values, in the function f, it looks like when I input the value 4, I should be getting back a value of 7, right? So in g of x, the function is just going to see, when I input a positive 4, what's the function seeing? It's seeing a value of negative 4, isn't it? Right? Everybody get that? So when I input positive 4, the function sees negative 4, and what is the red graph supposed to do at negative 4? At negative 4, it's supposed to be some really big positive number, right? Yes, sir?
Would it be bad if you just like translated it to the left instead of reflecting it?
Well, I mean, so if the question is, can you represent that reflection with the translation? Yeah, you can, right? You can, but here's why that doesn't work.
Because if you have names for the points, they're gonna change.
Or if I do this, if I go,
Oops, not
this guy right here. Okay, so let's do this. So we're taking away any translations, right? All we're going to do is a horizontal, we're just going to multiply by negative 1, right? Inside. Even if I add a horizontal translation to this, let's do, I got to change this a little bit. So let's make this new graph.
parabola. Parabola five.
No, we're not. No, we're not. So let's do this. Let's take f of x equals square root of x minus 4. Okay? So if I just translate that, the suggestion is to get it over to here, I could just translate it to the left by 8, right?
Yeah.
Is that what you're saying? Okay, so let's do that. That's easy to do. We can call that g of x. And that's going to be the square root. That's just going to be f of x plus 8,
Yeah.
right? We translated it. What's the problem, though? That's different, isn't it? If we do h of x is a reflection of f of x, so f of negative x, that's a reflection.
But what if it's a parabola?
Okay, well, if it's a parabola, yeah, then it works because parabola has some additional symmetry there, right?
Yeah.
But in math, I mean, you're right. In that one case, we can. But the question you always kind of have to ask yourself in math is, how general is something, right? And you got to be careful. And I'm not. Maybe you were just. I mean, you weren't necessarily implying that this would always work, right? In this case, it does. But in math, you got to be careful about overgeneralizing, because to think that just because we've got a function that is symmetrical, that a reflection is the same as translation in this one case, you can't generalize that, right? You can't generalize that. It wouldn't work. Okay. What about something like this then? What if we want to write f of x in terms of g of x? If g of x is a reflection of f of x over the y-axis, what's g of x going to be? Over the y-axis.
Negative.
So
Yeah.
negative f of x,
Yeah.
we agree?
That's
What,
what I
which
see.
axis?
The y-axis,
Oh,
we're gonna
yeah.
reflect it over the y-axis. So is that gonna be a horizontal or a vertical reflection?
Horizontal.
Horizontal. Okay, so then if it's a horizontal reflection, which variable are we gonna have to multiply by -1 to switch?
X.
X, because x is the horizontal variable, right? So it's gonna have to be f of negative x. Now, obviously then if we're gonna reflect over the x-axis, that's a vertical reflection. So we're gonna multiply y, which is the whole function. Right, that whole thing is just y, isn't it? Right? So we multiply the whole thing by -1. Okay, now let's take a specific function. What if we have something weird, like we haven't talked about these. This is an exponential function. Base 7 exponential function. So the function f of x equals 7 to the x. So first of all, let's just get a feel for how would we even evaluate a number for this? What if we wanted to calculate what's f of 3 for that function? 7 to the third, right? Because wherever we have an x, we're going to replace that with a 3. So that'd be a big number, right? 343 or something crazy like that. So what's going to be, what am I going to do then if I want to make a reflection of this thing over the x-axis? So I want to take this function, f of x, and I want to write it, g of x is going to be written in terms of the exponential function. What's that going to look like if I want to reflect the function 7 to the x over the x-axis? Is that a horizontal or a vertical? It's a vertical. So what do you think? Yeah, it's just going to be whatever the function is, right? F of x is equal to that whole thing. And so we're going to multiply the whole thing by -1. Everybody get that? Okay, what if we want to reflect this over, let's reflect it over the y-axis. Yeah, that's weird. I mean, and I purposely picked a function you were very unfamiliar with, right? Picked one that's very different, you've probably never seen it before. But the same recipe holds here. All I've got to do is I've got to replace the x with a negative x, or multiply all the x's by -1. Yes, ma'am?
Could you just put 1 over 7 to the x?
You could. Yeah. You could on this one. Okay, I mean, that's because it's negative. She's invoking a power, a property of exponents. Question?
What does one of these functions look like when you graph it out in Tesla? Like
That would look like, it would look like this. 7 to the x would just look like,
It would look like an S. It eats.
it's just going to look like that.
very steep, very quickly.
Yeah. Get steep. The further you go to the right, steeper it gets.
I thought it was.
Okay, what about something like that? It's a little trickier. This time, we got a bunch of stuff. It looks like we've got some translations going on also. But if we want to reflect this over the x-axis, the whole thing over the x-axis, what would we have to do? Over the x-axis. Now, you got to be careful because I get why people jump to that conclusion real quickly because they're saying x-axis, right? And so you're thinking, oh, x, that's horizontal. But if we're making a reflection over the x-axis, is that a vertical reflection or a horizontal reflection? Vertical. So I would have to multiply, I'd have to multiply the whole thing. I have to multiply the whole thing by -1, right? Got y is the whole function this time, right? Okay, questions on that? Right? Y is f of x, and that whole thing is f of x. Okay, how about that? I used to already did one like that. Let's get that. So now there's a lot going on, right? And you have to be very careful about the order. We kind of have seen this a little bit, right? We've already seen in some of our explorations of what these graphs look like that the order in which you do this stuff is important. We saw that a little bit yesterday with the horizontal dilations, right? If you translate first and then dilate, we get a very different result than if we dilate first and then translate, right? So what are we doing here? First thing we're doing is horizontally stretching by a factor of 9. Then we're translating right by 1. Then we're reflecting over the y-axis. And then we're translating up by 9. Okay, so let's just kind of add this stuff piece by piece, how about, right? So let's start off, maybe we'll just color code it. So the first thing we're going to do is this. Stretch by a factor of 9. So we're starting off with f of x is this, right? How do we horizontally stretch by a factor of 9?
Multiply by 1/9.
So we're going to multiply by 1/9 where?
Inside.
Inside. Okay, so we got a 1/9 inside. Okay, next issue. How do we translate right by 1?
Subtract 1.
Okay, got to subtract 1, but I have to be careful about that. I'm subtracting 1 inside the parentheses, right? So inside x, I'm subtracting 1 from x only, right? So here I'm going to need to do a set of parentheses and do that, right? Okay, so now we're going to reflect over the y-axis. How do I do that? So I'm going to put a negative out front, right? Let's make those a little bigger so they don't look like numbers. And then last issue, I'm going to translate up by 9. So plus 9. Okay, now does the plus 9 have to go in some kind of parentheses here?
No.
No, it doesn't, right? Because we're first going to flip it, and then we're going to translate the flipped graph, right? That's it. Okay? So, there's our answer, right? Oh, we forgot something, didn't we? Oh, we did something wrong here. We translated, what did we flip over? What did it tell us to do? Yikes, we did something wrong. Okay, so where does that have to go then? If we're flipping over the y-axis, that's a horizontal translation, so we're multiplying the x variable by -1. Right? Okay, make sense? That's a lot. Try that one. You got your notebooks. Just try this real quick. Try this on your own. Okay, so let's start off with our absolute value of x. What are we going to do here? What's maybe one thing, Kendra, let's do the first thing. We want to horizontally stretch by a factor of, did we just do this one? That's different. Okay, horizontally stretch by a factor of 9. So what's that going to be? 1/9, and that's,
Oh, right after the first absolute value and then the rest.
okay, so inside by 1/9,
Oh,
good.
yes.
Good, good. No, that's good. Translate, you're fine. Translate right by 1. So that's
Inside the X.
inside.
Negative one.
Okay, so -1, and I've got to do,
Negative two.
okay, good, because I'm just doing that only from the X, right? I subtract that from the X to move it horizontally. Now I'm going to reflect over both coordinate axes. Now, does it matter what the order is here?
No.
Does that make any difference? Okay, so if I'm doing both, I'm gonna have, that's gonna flip me over the x-axis,
And that one's.
that's gonna flip me over the y-axis, right? And then finally, if I go up by 5, okay, agreed?
Yeah, bud.
Okay, good, good. Okay, threw you a little curveball here.
Oh, that is not.
Ooh. Curveball. I'll say curveball.
Think what they're asking you to do here. They're asking you to, first we're gonna translate this thing left by 2. And then if I say horizontally stretched, what do we mean by horizontally stretched?
Curled bar.
Where am I stretching it from though? Like if we're stretching, like if I take a graph,
From the vertex. From the Y.
okay,
This was a curveball.
it was. This was a major curveball.
And you had a good answer.
Okay, so like if I do, here's my parent graph is there. There's my transformed graph. If I want to translate it horizontally, like if I put in a 1/2, what did I do? Well, I stretched everything.
Touched it all.
I stretched it all, but where did I stretch it from?
From the. From the.
Oh, yeah, there you go. Whoops. So there's,
But I was doing absolute value.
well, I picked a different one. So we got square root of x. I mean, we'll get to the absolute value one in a second.
From the vertex.
Let's go ahead and make it absolute value. So if I multiply this thing by 1/2, it does what you'd expect, right? It stretches everything, but where is it stretching it from? You can literally think of it like if the XY plane was written on a rubber mat, and I take the rubber mat and do what with it?
Well,
Stretch it, but where am I stretching it from, though, is my question.
the.
The middle, which is the
Horizontal.
y-axis. Everything is getting stretched from the y-axis. Now, if, and you listen carefully to this, because this is people have trouble with this. So if the function, if its special point is, and they typically are, is on the y-axis, usually it's going to be at the vertex, or at the origin, right? Then it appears as though I'm just growing this thing from its special point. But that's really not the case. What they're asking us to do here is they want us to translate left by 2 first, and then we're going to horizontally stretch the space, right? So look at the effect of that. If we do exactly what we're told to do here, the first thing we're going to do is translate left by 2. How do I do that? Plus 2. Okay. Now, if I want to stretch the space horizontally, I'm really only multiplying the x by 1/2, right? Look what it did. Right, so instead of this thing, now instead of it being translated by 2, look what happened. Well, it is translated by 2, but that point that was at -2, when the space gets stretched away from the y-axis by a factor of 2, that vertex gets stretched in the space out to -4.
Oh, so
Right.
the point on the y-axis is,
So this point, right, when the whole thing got stretched, it got moved from there to there, right? But that's very different from what we did in the last examples. In the last examples, we didn't do it that way. We stretched it first. If we go back and look at these other, we horizontally stretched first, and then we translated, right? That's different than what we just did here. Is that the one we're on? Yeah, right there. How would I have to change this in order to horizontally translate it, or to stretch it first and then horizontally translate it? Okay, that's where I'd have to add those parentheses around the x plus 2. Do you see the difference? Right? So now we've stretched the function by a factor of 2, but we've purposely put the vertex at -2. Okay, which is probably better? Which is more predictable and easier to do? That one is, for sure, isn't it? Right? So this is the way we choose to represent functional transformations. But sometimes we're going to be asked to do things that are different. We've got to recognize the difference, right? So this one would have been so that's really what we're being asked to do so far, right? So far, so good. So we translated it left by 2. We horizontally stretched by a factor of 2. Now how do we reflect over the y-axis?
x.
So the negative goes with x, right? But think about that. If I say 1/2 times -x, how would I probably want to write that? -1/2 x, right? So we'll put the 1/2 out in front, or the negative out in front of the 1/2. So there's our reflection. And then finally, what do we want to do? Add 5. Where do I add 5? Outside. And if I zoom out, there it is, right? Okay? Anybody see that? Okay, let's try another one. Oh, and so that's our answer? Okay? I mean, x over 2 is the same as 1/2 x. So try that one. Try that in your notebook. You can talk to your neighbor about it, see if you agree. That's it. Okay, any brave soul want to volunteer an answer here? What do you got?
-1 times the 1 9 times the 1 x plus 3. And then like x squared. He squared. Squared.
That's squared. You agree? Okay, so everybody get that?
I did, that's where I put my
Tanner did.
We have 1 minute.
I got that exact thing.
I wrote it right.
Oh, whoops, hang on, yeah, so we need, you're right, so we need another,
We need another parenthesis.
yeah, we need that, don't we? Let's make a bracket so we can see
Quantity,
it better.
quantity times the quantity.
Because this is all inside stuff, right?
Yeah.
It's gotta be inside the squared function. This is outside stuff and that's outside stuff, okay? All right.